to the next point. We should ensure whatever we see is clear.
That means work is being done. We can see that it is in opposite direction.
Hello, my wonderful students, viewers, and listeners at home. You're welcome once again to Kaduna State e-learning platform. Today on our lessons with chemistry, and the topic is air. As usual, I am your chemistry teacher, Mr. Philip Mamman. We'll be looking at air as a very important concept in chemistry. You'll be wondering, you've done air in your JSS and you have faint idea of what air is all about. But then there's so much more to learn when we'll be discussing air today. We'll be looking at the introduction of air, constituent of air, and percentage composition by volumes. We'll be looking at evidence for the composition of air. We'll be looking at fractional distillation of air. We'll be looking at uses of air. And of course, we'll look at flame. Flame, yeah, you've seen flame oftentimes. We'll look at air pollution. You've seen flame oftentimes. I'm sure you don't know what it entails. But today you will see a lot about flame. The Earth atmosphere is a mixture of gases. This is collectively called air. Like you always say, air is a mixture of gases. These gases include all important oxygen necessary for life and carbon dioxide, which photosynthesis depend on. Now, oxygen is very important to man, since we breathe in oxygen and we breathe out carbon dioxide or carbon dioxide. And of course, plant also uses carbon dioxide for their photosynthesis, which is the process where they produce their own food in presence of sunlight and chlorophyll. Now, constituents of composition of air and their percentages find out that air is made up of chiefly nitrogen. Nitrogen is about 78.909% of air in volume. And oxygen is the second to nitrogen, which is about 20.98%. By approximation, we say it's 21%. Then argon and other rare gases fall under 0.93%. Carbon dioxide is 0.03%. And other gases 0.003%. Of course, you don't expect that this is uniform everywhere. There are slight changes as you move from places to places, depending on activities that take place in those places. Now, if you look at the picture, you find out that the green zone there, which is the total, the largest component is nitrogen. And nitrogen will dilute other air. You see, oxygen is about 21% there. Then you have your argon, xenon, neon, hydrogen, helium, krypton, carbon dioxide. They all make up the small percentage in yellow there. So, as evident, nitrogen take over 3/4, that's 3/4 of air, while oxygen take about 1/4. The two are responsible for 99% of air by volume. Just oxygen and nitrogen, they make up 99% of air by volume. Now, we'll be looking at the evidence for the composition of air. Somebody will say, why do you say that air contains water vapor, for instance? Or how do you know that air contains nitrogen or carbon dioxide? So these are some of the activities that you carry out to show that these are components of air. For instance, water vapor. The presence of water vapor in air can be shown by simple experiments like substances that absorb water from air on exposure to the atmosphere and turn into liquids. They are called deliquescent substances. Example of these substances like sodium hydroxide. If you leave sodium hydroxide to air, after a while it will change from the solid state to liquid state. Why? Because it has absorbed moisture, which is water vapor from air. Now, other components include anhydrous copper 2 tetraoxosulfate 6. Ordinarily at anhydrous state, it is white. But when you expose it to the atmosphere, it turns blue. The evidence that it has absorbed moisture and turned into blue. You have anhydrous cobalt 2 chloride, who turns from blue to pink. Now, all these are evidence that the atmosphere or air contains moisture or water vapor. It's a common statement among chemistry students that carbon dioxide turns lime water milky, Actually, that's the test for carbon dioxide. So we'll be using that to test for the evidence that there's water in air. Say the presence of carbon dioxide in the air can be shown by sucking air through lime water. The lime water reacts with the carbon dioxide and turns milky. Now, since the amount of carbon dioxide in air is really small, about 0.003%, the reaction takes some time, about 30 minutes or thereabout. And you can see that in the equation. Carbon dioxide reacting with calcium hydroxide, which is lime water, and gives you calcium triiodocarbonate 4 and water. The calcium triiodocarbonate 4 is responsible for the milkiness that is seen when carbon dioxide is passed over lime water. Now, the next one will be the presence of oxygen. Obviously, oxygen is very, very popular because every human being breathes in oxygen. Every animal breathes in oxygen. So, how do we know that there is oxygen in the atmosphere? Of course, about other things, oxygen supports combustion. Oftentimes, if you have a candle burning and you cover it up with a bucket, it goes off or extinguishes because of lack of oxygen. So oxygen can be tested for, you can see the presence of oxygen in the air can be demonstrated by burning magnesium ribbon in air. That's combustion. The product is a white solid, which is magnesium oxide. What we have done is to test the fact that oxygen supports combustion. Look at the equation there, magnesium plus oxygen to give you magnesium oxide. Another way to test for the presence of oxygen in the atmosphere is by using paragalol, aqueous paragalol, which is benzene 1,2,3-triol. Readily, it absorbs oxygen in alkaline medium. So we can test for the presence of water in the atmosphere using alkaline paragalol. Now, we'll be looking at fractional distillation of air. Distillation is a very common term. We've seen it when we are discussing separation method. And we say distillation involves the evaporation and condensation of liquids. Now, there are two types of distillation, the simple distillation and the fractional distillation. And like I said in my previous class, the difference between simple distillation and fractional distillation is that simple distillation is used to separate liquids that have wide boiling point difference, while fractional distillation is used to separate liquids that have close boiling point difference. I gave you an example like petroleum, crude oil. When you take it to the refinery, the procedure is fractional distillation, where natural gas distilled first, followed by petrol, followed by kerosene, followed by diesel, then bitumen and other constituents, using their difference in boiling points. You can demonstrate that practically if you have two containers containing petrol and kerosene. If you dip your hand into both of them at the same time and bring it out, it's obvious that petrol dries faster than kerosene because petrol has a lower boiling point than kerosene. Now, that's the same procedure that is applied for the separation of air. You see that this is a popular method of separating a mixture with close boiling point difference. It involves the evaporation and condensation of liquid. In this process, the gas which makes up the air are first liquefied. Now you have to turn the gas into liquid. Somebody will be saying, oh, turn gas into liquid. It's very, very possible. I've said it oftentimes here that every matter can exist in three states. Can exist as a solid, can exist as liquid, and can exist as a gas. So you liquefy air and then separate any fractional distillation. Before the air is liquefied, any solid particle must be removed, such as dust particle. Removal of the solid particles prevent blocking of the pipe when the pipe is cool during liquefaction. So during liquefaction, these particles that are solid in nature, if removed, they will prevent the pipe from blockages, so that you have the clean air is liquefied as follows. First, the air is compressed to 0 atmospheric pressure. This raises the temperature. When you are compressing the air to 0, the temperature rises, so you must cool it, which is the second stage. The air is cooled. Then the third stage, the air is allowed to expand. This results in further cooling and liquefaction. Now, you know, cooling by expansion is what takes place at this level. Now, the mixture is heated in the fractionating column. Each component becomes gas at its boiling point and distill over. So a liquid often boils and turns into gas, and that's why we refer to it as evaporation and condensation. Once a liquid boils, it turns into a gas, and at a colder temperature, maybe using a condenser, the temperature drops and it becomes a liquid and is collected as a distillate. So below is the boiling point of the gases in order of which distill first, meaning that helium distills first because of the boiling point of minus 269 degrees centigrade, which is equivalent to 4 Kelvin. Remember that to get 4 Kelvin, you will add minus 273 to this. If you do the arithmetic, you get that. So 0 degree is equivalent to 273 Kelvin. So when you do the arithmetic, you will get the volume, the temperature boiling point of neon to be minus 246, which is 27. That of nitrogen to be minus 196, which is the same as 77. Argon is minus 186, which is 87. Oxygen is the same as 183, which is 90, minus 183. Krypton is minus 152, which is 121. And of course, xenon is minus 108, which is 165. Now, these are all the gases that are contained in air, and there are different boiling points. So at that point, when they boil, they distill out in that order. The one with a lower boiling point distill out first, then followed by that in the order I have mentioned earlier on. We'll be looking at the uses of air. You know, we cannot talk about the uses of air generally. We have to separate the component because each of them plays a role. You can see that the first one is oxygen. You see, oxygen is responsible for, is used for respiration. Respiration is the main purpose for fractional distillation of air. You can see that the reason why air undergo fractional distillation is because we want to get out oxygen, which is used to support life in our hospitals and so many places, because oxygen is needed in large quantity to support life during operations and so on and so forth. So oxygen can also be used in cutting of metal. I don't know if you have visited somebody that does welding using carbide. Now, carbide is put into a cylinder and water is added to it. A gas is produced. That gas is called acetylene. In modern chemistry, we call it ethine. Now, that metal, that flame is used for cutting and welding of metal. So, with oxygen that combine with acetylene to give you oxyacetylene flame, which is used for welding or cutting of metal. If you have visited a panel beater, works on your car, you find out that he used this kind of cylinder for either cutting or welding of metal. It's also used in steel industry to remove carbon from molten iron. Based on what we know in chemistry, once carbon come in contact with oxygen, it will give you carbon 4 oxide or carbon 2 oxide, depending on the amount of oxygen in circulation. So these are the uses of oxygen. Now let's look at the uses of nitrogen. Nitrogen is used in the Haber process. Now, what is Haber process? Is the way that we produce ammonia industrially in large quantity, commercially. And the reaction is such that hydrogen reacts with nitrogen in ratio 3:1, and ammonia is produced. Ammonia is a very important chemical compound. It is used in the manufacturing of fertilizers and so on and so forth. Now, nitrogen is also used as a refrigerant in food industry because of its low melting point. It has a cold sensation. If you watch football matches and when a player is injured, you find out that there is something in a container that usually used to massage the leg of that player. It contains nitrogen because of the cold sensation. It's used to massage the injury. So it's a refrigerant. It's used in food industry for preservation. I hope we are all familiar with what the refrigerant is. Now, nitrogen is also an unreactive gas. It can be used in aircraft fuel tanks to keep out air fuel mixture are explosive, meaning that air and fuel mixture are explosive. So if nitrogen is used, in other words, is to prevent air from entering into the mixture of fuel so that there will not be any explosion. Nitrogen is also used to keep oxygen away from hot metal surface during welding. So these are very few examples of nitrogen uses of nitrogen. There are so many other uses of nitrogen. I'm sure you come across them when you go through your journals. Then we have also uses of noble gases. When we say noble gases, we are talking about those gases that belong to the group 8 on the periodic table. We say they are group 8 or group 0 because they cannot lose or gain any electron. That's why they are called group 0. But of course, it involves the helium, neon, krypton, xenon. They are the family of elements which forms group 0 or group 8, like I mentioned earlier on the periodic table. With the exception of argon, they are present in air in small amounts. So meaning that it's only argon that is not present in air. They are all colorless gases which hardly react. Why do they hardly react? Because they have attained their octet state or duplet state. And in chemistry, when we say octet state, we mean they are stable. They have completed their outermost shell with 8 electrons, except for only helium that can fill the outermost electron with an outermost shell with 2 electrons. So let me take them one after the other. Argon. The most common noble gas is used mainly for filling electric bulbs. These electric bulbs, filaments, you see filament, then the gas inside is usually your argon, and it's used for lighting our homes and so on and so forth. What about neon? Neon is also used to fill electric discharge tube. I hope you understand these advertisement bulbs that you see with multiple colors inside. They are as a result of, they are called neon bulbs, or sometimes fluorescents that have colors like that. So neon is also used to fill electric discharge tube, an advertisement bulb. Now, helium is used in filling balloons. When I say balloon, I'm not talking about the balloon you blow with your mouth. I'm talking about the balloons that flies in the air. You can see them sometimes in your films. You see balloon flies in the air. Now, helium and hydrogen are both used to fill those balloons because they are light in nature. They are not heavy. The atomic mass of helium is 4. That of hydrogen is 2. But why is helium preferable to hydrogen, despite that hydrogen is lighter to helium? The reason is because hydrogen is combustible. I mean, if you use hydrogen to fill a balloon at high temperature, it can burst because hydrogen is combustible. But helium is non-reactive, so helium is better used in the filling of balloons. Now, xenon and kryptons, they are only ones with chemical reactions. Even though they have few uses, they combine with fluorine to form several stable compounds. My wonderful students, learners, viewers, and listeners at home, we have seen how what air is made up of, the percentages, composition, and the uses of air. We'll be looking at air pollution. When we say pollution, we mean the introduction of unwanted substances into the air that are harmful or toxic. So we say air pollution is the introduction of unwanted, harmful, or toxic substances into the air. Now, any substance present in air other than those gases mentioned earlier are impurities and can cause pollution of the air. Most air pollutions are caused by the burning of fossil fuel as oil, coal, gas, which contains small amount of sulfur, as the case might be. Now, this sulfur combines with oxygen and we form sulfur 4 oxide. When the fuel is burned, apart from the release of smoke and dust particles into the air, the sulfur impurities is converted into the gas sulfur 4 oxide. This gas escapes into the air and dissolve in rain to form acid rain. Now, acid rain is a phenomenon that exists when some of these gases, we call them acid anhydrides, That's oxides of non-metals like sulfur, like nitrogen. When there is rainfall in area where there is release of these gases, this rainfall dissolve these gases and fall down as acid, and we refer to it as acid rain. So you can see that then falls into rivers, land, and building, causing damages to life and properties. Other greenhouse gases such as chlorofluorocarbon, we have hydrofluorocarbon, and we have nitrous oxide that can cause the depletion of the ozone layer. I think of recent we have noticed that our seasons are occurring in a different manner. They are variable, they are not stable. This is because of the depletion of the ozone layer, which ordinarily is supposed to serve as a blanket to the Earth's surface. But because there is release of these gases by humans that tend to deplete the ozone layer, thereby creating a hole in the ozone layer and increasing the intensity of sunlight on the Earth's surface, there are floodings and so on and so forth as the natural disasters. In cities such as Lagos, Kano, Kaduna, Port Harcourt, Ibadan, air pollution is caused by carbon 2 oxide and the oxide of nitrogen released from automobile exhaust such as cars, trucks, generators, etc. I mentioned earlier on that there are two types of oxides of carbon. There is carbon 4 oxide and there is carbon 2 oxide. Now this carbon 2 oxide is dangerous. That is what is released when you keep a generator in an enclosed environment, or you keep a coal burning stove in an enclosed environment. Because of insufficient oxygen, it gives carbon 2 oxide. And this carbon 2 oxide attacks the hemoglobin of the blood. That means it stops the hemoglobin of the blood of oxygen. And this can lead to unconsciousness and eventual death. And that's why you hear that a family was watching TV with their generator they call Pass My Neighbor, and eventually they die. We have heard of so many news like that in previous times. So we will quickly look at the example of pollutions, and you have seen this pollution that are caused by different. Now lastly, we'll be looking at the flame. We have seen flame differently, and a flame is a region where gases combine chemically with production of heat and light. It is produced when substances burn mostly in oxygen. Flames are characterized by heat and light of several zones. The type of flame that we have luminous flame and non-luminous flame. The diagram we are going to see will explain to you what a non-luminous flame and luminous flame is. You can see the different zones in the flame. We have the red zone, which is the outermost zone. We have the hottest part, which is the pale blue region, and we have the moderately hot region, and of course another layer on the bottom, which is also a hot region. The reason is because of the concentration of oxygen at different layers. My wonderful students, as a roundup, you'll be looking at the Bunsen burner is used as an instrument or apparatus in the laboratory where we burn or we carry out combustion. So let's look at our assignment for today. The first one says define air, state the components of air and its percentage composition by volume. C says state one use each for the components of air in B above. Then we have state one evidence for each of the following composition of air. That's water vapor, oxygen, carbon 4 oxide. Then 3, state why it is dangerous to burn coal in a poorly ventilated room. And of course, define pollution. Lastly, you'll be looking at our reference materials. You can lay your hands on any of these reference materials, and of course my contact as usual, Philip Mamman, 08026598861. Once again, Philip Mamman, 08026598861. Or you can also call Ibrahim Umar at 07036202842. Ibrahim Umar, 07036202842. And lastly, Williams Ishaku at 08160670920. My wonderful students, have a wonderful time. Stay at home, read well, and coronavirus is real. Have a wonderful day.